This is our adaptive kayak paddle for the Senior STEM project of the year 2022.
Before we begin reviewing our project, let's meet the team. Hi, I'm Crystal,
Hi, I'm John.
And I'm Josie.
and we're part of the Galena STEM program and the graduating class of 2022.
Our project is made up of 4 parts: data and our problem statement, designing our prototype, testing our prototype, and the analysis of our prototype.
So let's jump right into our data and problem statement.
According to the United States government, 41% of veterans return with a mental health screening or diagnosis. 46% of veterans in combat report having difficulty readjusting into society. 41,000 people have upper limb amputations in the US. And lastly, a 2006 study showed that physical activity improves mental health, reduces anxiety, depression, and negative mood.
For our market research, we examined the benefits that physical activity has on the mental recovery process for returning veterans and for those who've undergone an upper limb amputation. In addition, we took into account the close proximity of our community to the pristine lakes and rivers of the Sierra Nevada before initiating our design. We wanted to create a product that would help veterans experience the popular water activities and aid in mental healing process that comes with the upper limb injuries.
Our problem statement, as shown, was designed to help veterans and those with upper limb amputations overcome their injuries and heal both physically and mentally in order to readjust to their normal lives. We want our product to help our consumers enjoy the recreational activities that are so popular in northern Nevada, beginning with kayaking.
With this in mind, let's move on to our prototype design.
First, few solutions have been previously made. David E. Oathout designed a paddle support for a vessel, but it has a difficult setup, limited range of motion, and the use of elastic members will result in the overall less durable design. In addition, it was not created with upper limb amputees in mind. It requires 2 hands for mobility.
This second solution was designed by a previous group of Galena STEM students. Though the device is portable and has a fairly wide range of motion, it was made for those who have limited grip strength and both functioning upper limbs. In addition, its height adjustability is not stable and does not account for variability in arm length. However, we want to take this design and improve it to meet the needs of our new target community.
To improve the design, we had several requirements that we wanted our product to meet as listed below. However, we specifically focused on the maneuverability and accommodations that would help upper limb amputees navigate through water.
We came up with several potential improvements and solutions throughout this process.
Our first design focused mainly on buoyancy, but we quickly realized that it was not a pressing issue and scrapped the idea.
Next, we decided to tackle the issue of durability and assembly. In the previous solution, all the parts were superglued together, but we wanted to implement a locking system in the upper and lower shells as illustrated here.
Our first idea to improve it was a stronger lock to keep the parts together. In this design, we believed that a line of bolts coming down the shell of both the upper and lower rotating spheres might solve the problem, but realized it would restrict some movement, and finding bolts that small would prove difficult.
This idea was added to see if we could improve the assembly of the upper and lower shells by keeping the locking system within the shell itself, rather than jutting out. However, it was not feasible since the parts were so small and delicate.
Here we thought that a simple strap on top of the upper shell would work, but it limited the mobility of the paddle.
The same strap idea is illustrated here, but for the lower shell. However, it would not be durable enough.
Lastly, we decided to improve the height adjustment system on the stem of the product. This design included a screw-like contraption that would allow one-handed assembly of the product and a bolt to keep it in place. This improvement almost made to the final design.
This design included all of the parts, including a button clip height adjustment system, a longer sliding base to adjust for arm length, small extrusions of the shells for a bolting system, and a wider range of motion.
Our design matrix is as follows. 5 is ranked best, 1 is needing improvement. Though as you can see, the highest scores on the 3rd row, our final design took elements of each person's sketches.
Our final design included Crystal's wider mobility ideas, Josie's height and length adjustment systems, and John's lower shell locking extrusions.
With that, we began testing our prototype.
The range of motion on a normal kayak stroke is illustrated in the first column below. However, as we move into the previous solution's range of motion, the range of motion laterally decreases.
But with our prototype, the range of motion increases again both laterally and front to back. In addition, we tested the time it takes to assemble the product, and if it can be put together with one hand. We tested the adjustability of height and length for different body sizes as seen below. Finally, we tested the success of the product in the water with a series of tests including the ability to row in a straight line and a figure eight.
After the tests were completed, we moved on to the analyzation of the prototype.
Throughout the project, we used several tools such as sketches, Onshape, and epoxy.
In addition, we used other 3D modeling software to 3D print each part.
Though we finished the project, we still have goals for the future of the project. After further redesign and improvements, we want to professionally manufacture the paddle support into a more durable material such as stainless steel or another metal, and then put it on the market for public use in hope of reaching upper limb amputees.
Thank you for watching, and we hope you enjoyed it as much as we did.